Okay, so I'm going to explain you where this is useful and how you can do it. So what is the mutational breeding? See, for talking basic learning outcome will be understanding what is that mutation, right, and how you can create polyploidy. Okay, because many application of this mutation is development of polyploidy. So first we should have a look on the terminology. What are the terminology, different terms? What is the meaning of different terms? Mutation. Mutation means sudden and heritable change in character of an organism, right? Sudden and heritable change in character of an organism, which does not arise due to segregation or recombination. Mutants, individual carrying a mutation that may be revealed using molecular means or identified by phenotyping tools. Mutagen, it is a physical or chemical agent that changes the genetic material. Okay, mutagen. This is a physical, this may be physical or chemical. Mutants over which you are carrying the mutation, right? The individual carrying a mutation will be called as mutants. You can identify them by using the phenotypic tools. And mutation, what is the principal identification of mutation? They must be segregated, right? They must be segregated in the next generation. So must be heritable, right? Must be heritable. So what is the mutational breeding? Means using the induced mutation, we can develop a crop. You can develop a crop, right? Utilizing induced mutation, you can develop a crop, right? So from here this mutation breeding started. So if you see, the mutation breeding was first initiated by scientist Stadler in 1928 in the plants, right? For the purpose of crop improvement. Okay. So because already you know that every character, phenotypic character is decided by their genes. So if you are changing the genes, you can have the visual character. So there are two types of mutation: spontaneous and induced mutation. Spontaneous means suddenly, okay, without any reason. Induced means you are targeting, you are using certain agents like X-ray, UV rays, and then chemical agents, and nitrous acid, malic, hydrogen, EMS. Okay, the agent used for producing them are termed as mutagens. Okay, utilization of induced mutation for crop improvement is known as mutation breeding, right? So you got the point. What is mutation breeding? We are inducing a mutation in the crop. This is called the mutation breeding. Okay, and who carried out the mutation breeding? Stadler, when 1928. Okay, and what was the purpose? Crop movement, and this was called as the mutation breeding. What kind of mutation you can use? You can use the physical agent like X-ray, UV rays, okay, or you can use the chemical agents like nitrous acid, malic acid, hydrogen, and EMS. Okay, so agent for producing them are termed as mutagens. So chromosome number, you can see what kind of changes are there. There are two kind of chromosome number: euploidy and aneuploidy. So if you are changing the chromosome number in such way that the whole set of chromosomes is going to loss or gain, then this is called as the euploidy. You can increase the set of the chromosome or decrease. And what is the aneuploidy? This is a kind of gain of one or few genes. This is not a set of genes. That's why aneuploidy means odd number. Odd number you can see 55, 57. That's why the formula is given 2n minus 1 for monosomy, 2n minus 1 for monosomy, 2n plus 1 for gain of chromosome, 2n plus 1 for trisomy, nullisomy 2n minus 2. Okay, polyploidy. Euploidy, change in the number of chromosomes which may involve loss or gain of whole set of chromosomes called euploidy. Okay, so an organism that has more than two haploid set of chromosomes is called as polyploidy. In plant, polyploids are common, right? It is estimated that about 1/3 of NGS are polyploids. Okay, okay, clear? So polyploidy, the first polyploid was reported in The Kyrase mutant and autotetraploid on the evening primrose. Okay. Characteristic of polyploids. Polyploid have larger cell size than the diploids. The guard cell of instrumenta are larger, right? So these are the some features of the polyploids. Are larger size will be there. And how the polyploids are going to be derived by the mutation. Either you can do it by spontaneous mutation or by the induced mutation. Or you can use the physical or chemical agents. Physical agents you can use heat or cold treatment for some time. Colchicine is used popularly for the polyploid production. Okay. So colchicine is most often used. Colchicine, a poisonous chemical isolated from seed and bulbs. Okay. Called as the colchicum, colchicum autumnale. Colchicum autumnale. Okay. What is the effect of colchicine? It blocks spindle formation and thus inhibit movement of sister chromatid to the opposite poles. Block spindle formation and inhibit movement of sister chromatid to the opposite pole. Okay. So this results in the aneuploidy. Okay. Colchicine is effective only in the dividing cells. Right. So as a result, the chromosome number of cell is going to be double. But if it's blocking spindle formation, then movement of sister chromatid is stopped. As a result, 4 become 2 if they are equally dividing. Okay. But if they are not dividing or not moving to the opposite pole, 4 become 4. So that's why the chromosome number is double. Colchicine treatment, you can see almost 0.2% is enough because keep up concentration may be very, very toxic. Okay. So depending upon the level of ploid, there are triploid, tetraploids, pentaploid and hexaploids. Okay. Triploid means 3x, tetraploid 4x, pentaploid 5x, hexaploid. Okay, what is the hexaploid? 6x. Means what? What is the x? Tell me. What is the x? What is the x? Who will tell me? Ashish? Akash?
Chromosome, sir.
Number of chromosomes. Yeah. So type of polyploid, autoploids and illoploids. Autoploids and illoploids, right? Polyploids are generally divided into two types, autoploid and illoploids. All the genome present in polyploid species are not identical. When all the genome present in polyploid species are identical. Okay. So an organism that has more than 2 haploid set of chromosomes is called as polyploid. 2 haploid set of chromosomes, right? So maybe autoploid, maybe illoploids. When all the genome present in polyploid species are not identical. Type of polyploid, autoploid, already discussed. Autoploid means when the chromosome genome present in polyploid species are identical. It is known as autopolyploid. And this is AAA, for example. Right? So potato 4x, coffee 4x, banana 3x, auto triploid. So they are odd in number, so they are sterile and no seeds. Okay. Sweet potato, auto hexaploid. Auto hexaploid, auto triploid are successful, while auto triploid are not successful. So these are the autopolyploidy which we can create by the mutation, and they are helpful in crop improvement. How they are helpful? Because autotetraploid may be useful in breeding. Triploid clone of T have been developed, producing triploid line from monoploids and produce seedless fruit. This is the most important, production of seedless fruits by using triploid, because triploid is sterile. So if they are sterile, they will not going to produce any seeds. That's why they are called as the seedless fruit, seedless watermelon, tomato and grapes. Seedless watermelon, tomato and the triploids are generally highly sterile. Yellow polyploid, when all the genome present in polyploid is not identical, yellow polyploid. Polyploid genome from more species present polyploid are most likely to be doubling in a hybrid. Okay. So production of yellow polyploid. Production of yellow polyploid involves two steps: production of F1 distant hybrid and chromosome doubling by Colchicine. Chromosome doubling by Colchicine. So in some distant hybrid, occasional unreduced gametes are produced. These unreduced gametes unite to give rise to yellow polyploid. Yellow tetraploid best example is Raphinobrysica. What is Raphinobrysica? This is the F1 from the class of Brassica Garcia, Cabbage and Raphinus sativus. Cabbage and Raphinus sativus. तो इसके पहले थोड़ा सा म्यूटेशन के बारे में डिस्कस कर लेते हैं, राइट? Just a minute. Now this is the wrong. I can see induced mutation. Induced mutation are of two types: macro mutation and micro mutation. You can see macro mutation. This is a large phenotypic effect recognizable on individual plant. In contrast, micro mutation has a small phenotypic effect that cannot be recognized in individual plant. What is the type of mutation? There are different types of mutation. For example, forward direction, reverse mutation, right? Forward and reverse mutation, somatic and germinal. Division of the site, they may be nuclear or cytoplasmic, character morphological, biochemical, visibility. Macromutation shows spontaneous induced. What is the induced mutation? Induced mutation whenever you are using any radiations. What are the radiation? Electromagnetic wave traveling the space are called as the radiation. They are called as the radiation. Electromagnetic wave. What is the radiation? Electromagnetic wave traveling in space is called radiation. Okay. Treatment of plant material with physical radiation to induce mutation is irradiation. Okay. Right. Irradiation method of plant breeding are also known as radiation breeding. Radiation breeding. The radiation used in plant breeding are of two types: ionizing radiations, non-ionizing radiation. Okay. So electromagnetic traveling at high speed through space is called radiation. That is, treatment of plant with physical radiation to induce mutation is called irradiation. Radiation method of plant breeding are also known as radiation breeding. The radiation used in plant breeding are of two types: ionizing radiation, non-ionizing radiation. So ionizing radiation, there are type of radiation: X-ray, gamma rays, alpha particles, fast and thermal, neutrons, and UV rays. How many types? X-rays, gamma rays, alpha particle, right? Okay. X-rays, gamma rays, alpha, fast and thermal neutrons, UV rays. Clear? You are getting my points? So this is the type of radiation. What is the property of X-ray? They are very penetrating and non-particular. What is the mode of action or change causes? So induced mutation by forming free radical and ions cause addition, deletion, and transition. Gamma ray is very penetrating and non-particulate. Okay. While gamma rays induced mutation by segregation from tissue cause addition, deletion, and transition. Alpha particulate less penetrating and positively charged. Alpha particle act by ionization and excitation causes chromosomal and gene mutation. Fast and thermal neutrons particulate neutral particles highly penetrating, and fast and thermal neutrons causes chromosomal breakage and gene mutation. Okay, so alpha particle is active by ionization excitation, right? So this is important. Gamma rays for deletion and transition, X-ray for deletion and transition. Okay, and thermal neutrons for chromosomal breakage, UV rays for chromosomal breakage. So what is the steps in the mutation breeding? Right, mutation in the breeding means you have to select the variety which you want to improve, and then undergo the treatment, and you should see dose of mutagen. This should not exceed LD50. LD50 is what? Means 50% of the loss. Means this is 50% of any toxic component can be used, because this is not going to wipe out all the organisms. So 50% concentration, that is having the minimum toxicity. It's enough to create the mutation. So giving mutation treatment, irradiation by chemicals. So irradiation immediately at the benefit, right? But chemicals it are pursued and desired mutation. Handling of mutagen, treated population in trials, release of variety. So these are the easy procedure by irradiation, right? You can undergo yield trials and you can see the varieties working better or not. What is the procedure of mutation breeding? Treating a biological material with a mutagen in order to induce mutation is called as the mutagenesis. What is mutagenesis? Treating a biological material with a mutagen. This is a process. Mutagenesis is a process. You can induce mutation. You are inducing mutation. So you are creating a process. What you are doing? You are creating biological material with mutagens. Then mutation is created. Then certain genes are deleted or added. Okay. Other points. Mutation breeding process consists of following steps. Objective of the program: choice of material and plant part to be treated. What is the objective? What do you want to do? You want to improve the variety. So where you are targeting the mutation, because all the mutation are dangerous. You cannot go for the. So what is mutagenesis? Mutation you are creating. So choice of material is important. Their objective and what you can treat for the mutational breeding. You can treat seeds. You can treat pollens. You can treat vegetative propagules. Sometimes complete plant can be treated with mutagens. Selection of plant part varies with crop plant. Seed are the best part in sexually propagating plants. Okay. So mostly mutational breeding is done in the self-pollinated crops, where self-pollinated crops it can be also applied in the seeds, that is sexually propagating plants. So mutagen treatment reduces germination, growth rate and fertility of the organism. So that's why every time is not possible. Every time is not beneficial. So damage increases with increase in dose. Okay, so you are increasing the dose, high dose, the damage will more. So also it should not be exposed for very long time. Right, optimum dose of mutagen is measured LD50. LD50 means what? Dose of mutagen that kills 50% of the organism. 50% of the organism is going to be dead. By use of that dose, it means this is LD50. Beyond this, it will be lethal. It will kill all the organisms. So we have not to kill all the organisms. Other than what we have to do, we have to expose certain minimum amount for very minimum time. And I said that only limited amount of micro plant should be individual should be killed, because if the gene will be there, powerful gene will be there, then only they are going to survive. Okay, so that's why LD50 concept is very widely used in the mutation field. Okay, so an optimum dose is one which produces the maximum frequency of mutation and causes minimum killing. So minimum killing is main the target, and those close to LD50 should be very limited amount should be dose there. So that minimum killing is desired. So what is how the giving mutagen treatment? X-ray radiation is given in the X-ray room. Gamma ray radiation by the gamma garden. Neutron treatment is given by the neutron flush coming from generator. Beta rays treatment is given in the laboratories. Yeah. So now you can see the machine. This is the X-ray machine where you can create a mutation. Right? Where this is the specialized chamber. So outside effect is not visible. Gamma garden, you can see this is a closed chamber that highly useful for irradiating the gamma, development of the gamma rays. Neutron generator, they are creating the neutrons very high speeds, and you can see they are applied in various things like microcutting, mutagenic treatment, explant isolation, shoot regeneration, carving of implants, plus substitution, actually mutation. So handling of mutagen treated population, treatment of seed on vegetative propagules commonly produces chimera. Okay, if you are going to treat a seed and vegetative propagules, what you can see? You can see production of chimera. So chimera is an individual with one genotype in some part and another genotype in others. Means this is not a this is a different organism. One genotype of one plant and another genotype of other plants. So this is a chimera. So clonal or sexual generation with selection are necessary for stable genotype. Mutant allele are generally recessive. Dominant mutation can occur, but it is rare. So generally mutation is recessive. So how you can go for the mutational breeding? What are the steps? So Mutagenesis of seed, pollen, vegetative part or tissue culture, plant or completed seeds or vegetative propagules. Vegetative propagules are written as M1, B1 and treated seed M1. Population of plant cuneiform seed M2 or vegetative parts M1, B1, B2. Selection of desired mutants may start in this generation or later. Continuing selection, genetic conformation, multiplication, and stabilization of field performance of mutant lines. Comparative analysis of mutant lines during different years and different locations. So official testing before release as new varieties first. Okay. So what you can target, this must be treatment should be there, and then selection of the desired character, and then continuously selection. And for the genetic conformation and see the they are stable, they are heritable. Then only you can see there is a mutational breeding, and you can compare with your normal lines. So what is the advantage of mutation breeding? Artificial mutation induces sufficient variability in plant to induce improvement of varieties. So mutation breeding take less time than conventional breeding. That's why the people are applying it, because conventional breeding takes a very long time. It may take 7 years, 8 years. But mutational breeding it can be completed in 2 to 3 years. Because after the mutation, we are going for the F1. And then you can see F1 has the desired character now, and then you can verify its genetics by crossing. By crossing can give you the idea of genes, they are heterozygous or homozygous. And heterozygous, then they are more dangerous, because heterosis will be there. So improved morphological character you can identify, you can see the physiological changes, you can obtain a disease-resistant plant, you can see quantitative characters also, and in the resulting improvement of yields. If you are carrying out the polyploid, so what will happen? This is muskmelon, seedless plant, bigger size. Okay, so morphologically they are very beneficial. Physiological character, you can improve the color of the roses, more shiny, more red, more bright. Because sometimes fruit and sometimes flowers rate is decided by the colors. If they are more bright, having the more bright color, they will have more price. Okay. And disease-resistant plants, because they are saver, they are going to save your money from buying the fertilizers. Okay. So what is the limitation of mutation breeding? You can see a desirable mutation is very low. And the free institution have the facility to conduct mutation breeding for each and every step of mutation breeding. Financial assistance is required. This is very, very costly. Okay, and also very dangerous. So must have a proper facility to conduct it, and that can be provided only by the government. Okay, identification of micromutation is called pleiotropic one gene expression to a more unrelated effect. Okay, so now you can see creation of yellow polyploid because of mutation. Okay, so you can see their wider effect in the development of bread wheat, Triticum aestivum, right? This is yellow polyploid, okay, and evidently Triticum aestivum has been investigated by many workers. That's also A genome is Triticum monoicum, B Agelus speltroides, and D Agelopus scarosa. So you can see a closely allied species of grass, where it looks like original crops. So when you are crossing the Triticum with Agelopus speltroides, at 2 n is equal to 14, so n is equal to 7, right? Both are the same, n is equal to 7. Means if you are crossing, you are getting the 14, it's sterile. You are getting the colchicine, if you are treating with the colchicine, then you are getting the double from genome. For example, AB was the genotype, and now you can see double A, double P, right? So this is a yellow polyploid. What is this? This is yellow polyploid. They are fertile. They are fertile. And if you are crossing this AABB variety with the DD variety of Aegilophus spirosa, then you can see this again is sterile. Then again you are making the hexaploid, means AABB 6 years. Okay, now this is a fertile. Now similarly you can do the triticale by crossing with the rye N7, B3 and 21, and you are getting the triticale 4 is equal to 28. But to make them fertile, you have to treat with the colchicine. Colchicine making the 56, right? So this is the crossing, crossing by the crossing and mutation. You can change the morphological feature. You can make them fertile from the sterile. What is the triticale? Triticale is mostly asked in examination. Triticale is produced by the yellow polyploid. Rapina brassica, and triticale is the best example of yellow polyploid. So triticale has combined the favorable feature of two parental species, intellectually and gain quality of heat and hardiness. Applied present triticale are comparable to those of the best wheat varieties. Triticale is thus man-made cereal. Why this is man-made cereal? Tell me. Who will tell me? Why triticale is man-made cereal? Who is the most intelligent? Sara, Sritika, Swasti, Chandra, Chandan, Vivek, Coming Bomb. No answer? What is the feature of triticale? Tell me. Have you heard about the triticale? This is mostly asked in examination. Sritika? Yes, please.
Sir, they are synthetic by man. That's why.
Man-made cereal. And how they are created? How they are created?
They are created from two distinct genes or species plant.
Rye and wheat. Rye and wheat, when they crossed, then initially they were sterile. But after treatment with the colchicine, they are now fertile. So that's why this is called as the synthetic yellow polyploid. And they are best performing in the world. Okay. You can see the good yield, good varieties, good seed. So quality of wheat and hardiness is also going to improve because of the rye. Why? What is the use of rye? Why man selected rye? Because earlier wheat was very soft. They are easily degraded by the pathogens. Okay. If anything is soft, who will eat? Human or pathogens? Tell me. Anything is very soft. So who will eat first if they are growing in the field? Who will eat first? Human or pathogens? Pathogen.
Pathogen, sir.
Very good. Very good person. So pathogen is eating. If pathogen is eating, then human is hungry. Okay? There is no hunger because human has a lot of hunger. Right? Akashdeep? Am I correct? So human thought that how the seeds would be very hard. How you can make them hard? If you are treating with if you are crossing with the rye, because you see rye is very hard, very tough. So softness of the wheat, hardiness of the rye. This is called the triticale. Right? What is the triticale? Hardness of the rye. Right. Now, even if a lot of pathogens are there, they are not going to eat easily because the upper surface is hard, seed surface is very hard. And also they said that is eatable, it's not very tough. With the flour, you can make bread, chapati. Right? That's why triticale is mostly asked in the exams. Wherever you are going to give the exam, mostly they are asking about the critical. The best example of yellow polyploidy. What is yellow polyploidy? Yellow polyploidy is the part of mutational breeding. What is mutational breeding? If you are changing the chromosome, right? If you are changing the chromosome, changing the gene, right? If you are changing the desired character because of mutation. Mutation you can adopt and mutation can create either sterile or fertile. But fertility you can regain if you are getting the sterile. How you can regain the fertility from the sterile plant? Tell me. How will you regain? What you will do? Chandan, Chandra Gula, all the intelligent genius students, Avneet, Sahara, Kritika, Smith, tell me. Then we try. Hello. How you can make the fertile if you are getting sterile? By treating with the pulses. By treating with the pulses. Okay. Clear? Any doubt? If we are getting any seed, for example, after the crossing, they are sterile, asses, then how will you make them fertile? This. How will you make them fertile? Very simple. You treat them with the palchi seed. I have told you, na? Every time you can see this is palchi seed. Rye and wheat. This was sterile.
Yes, sir.
21 is odd, 21. But palchi treatment give them 40. That's why you can eat the wheat. Because now they are fertile. So palchi is an important part. Note that. If you are getting odd number like rye and wheat, 7 and 14, you are getting 21. Right? You are getting how much chromosome number? 21. But this is the sterile because this is odd number. So you cannot eat the wheat. You have to treat them with the palchi seed. Okay. So this is. So once again we will get back. Just go for the poles. Pole start करें. We will start. Okay. Remember the Hartison here. Doing the hybridization with male and female. Here you don't need that. Right. You are just need the seed and produce some kind of vegetative part in the mutation. Advantage a lot of advantages there of the mutational breeding. Okay, lot of advantages. Minimum land or labor varieties because morphological, physiological character, resistant and character, limitation of mutation breeding. Then what is the limitation? Frequency is very low, very costly, distribution of micro mutation is essential, very harmful, and may be there more than one gene may be affected. That is all about the mutational breeding, about the yellow polyploid. Okay, so next time we can study, we can check the syllabus what we are going to study next time. Syllabus is this is the syllabus. We have covered part 6, plant reduction, selection, hybridization, population increasing, many famines. Means people were dying because of hunger, because of no food, and also there is now overpopulation. So feeding is very difficult task. So government is unable to feed them. So this is the responsibility of agriculture scientists. How to increase this revolution. So that's why the green revolution was targeted. And what is the difference between green revolution and traditional agriculture? Green revolution introduced high yield crop variety, right? Are going to introduce high yielding crop variety. We will perform H by CB. What is the high yielding crop variety? Means constant improve. Then chemical fertilizer came into existence. Now the people are using the same practice. High amount of chemical fertilizer, high amount of pesticide. Now what is the current revolution given by the J. Narayan? The webinar was conducted just. All you got your certificate? Avita?
No, sir.
So, if you have participated, then only you are getting the certificate. Your attendance was taken from the Zoom. Okay. So, not getting it's your responsibility. Okay. So, if you participated, then J. Narayan has given a new word: green revolution versus IT revolution. Okay? Digital revolution. That was very important. Why digital revolution? Because you must learn. So we are going to start very soon new course for you people, and this will be the 6-month certificate course based on the learning agri informatics, software based learning. How you handle GPS, how you collect the data, how you go for the precision farming. That's in one word. That's precision farming. Why? Because from the green revolution practices high amount of use of fertilizer and pesticide. That is not recommended. Okay? That is not recommended. What is recommended? Precision farming means if you don't require, don't use it. If you are requiring very small amount, use them very small. And also new irrigation technique now implemented. At that time, flood irrigation was there. Now what we are doing now, we are targeting the drip irrigation. Earlier this was a flood irrigation. Now we are doing the which irrigation? Drip irrigation. Okay. So that's why the things are changing. We might be teaching the old things, but also we are teaching the new things and giving the information via various webinars, various. So you must have the latest update and you must participate in that innovative learning. So I can say high yielding crop variety. The first miracle seed was IR8, produced via this plant breeding techniques. Okay. So that's IR rice variety was here because there was a cooking quality issue, pest resistant issue. IR8 was very successful in that regard. If you are using the proper fertilizer and chemicals, this is 5 times more gain per hectare. This was a kind of, that's why this was called as the miracle seed, and this plant was distributed well in the Africa. Now, agrochemical fertilizer had not been used on traditional crop variety, promoted vegetative crop without increasing yield. Pesticide use necessary in many high yielding variety seeds. So, but also some seeds were pest resistant, but some seeds were poor, having the poor pest resistance. That's why the high amount of agrochemicals is required. So now you can see this is now people are stopping. Don't use chemical. Why? But this is harming our tissues, our cells, our lungs, our brains. This is very toxic. If you are eating daily chemical based grains, chemical based vegetables, obviously corona is looking for you. Okay. So try to use very less pesticide and chemicals with food. They are very, very dangerous. Most fertilizers were imported from America. So green revolution, also known as seed water fertilizer pesticide technology. Okay. So in 1965, Mrs. Indira Gandhi decided to start this green revolution because this was very successful in advanced country, European countries. So Ms. Swaminathan was the scientist, lead scientist of this project, Green Revolution. And basically this was started in Punjab and Haryana. Okay, that's why in Punjab you can see people are very less using the organic fertilizers. They are heavily using chemical fertilizer. And what is the history of Green Revolution? You can see the Green Revolution started from the Norman Borlaug. That was the American scientist. So he conducted research in Mexico and developed new disease-resistant high variety of wheat. Inspired by that work in Mexico, Green Revolution was started in the other part of the world. For example, in India, the population was increasing and food was very less. So the government has decided to take this initiative, and because of that, you can see there is a high use of fertilizer and irrigation. Water table was there. Method using the Green Revolution, seed with superior genetics. That's why I was making you study this technique, mutational breeding. Okay, mutational breeding was required there to improve the superior seeds, double or multiple cropping system, high variety seeds, and use of pesticide and fertilizers. But at that time, this was not revealed that genes are responsible for. You can transfer the gene from other crops which are protected from the pesticide and fertilizers. Right? So that was the idea. Use of modern machinery, tractor, harvester, thresher, expansion of farming areas. Causes of Green Revolution. High variety of seed, chemical fertilizer, irrigation, multiple cropping, modern agriculture machinery, credit facility, agriculture research, plant production, rural electrification, soil testing, and soil conservation laboratories. So these were the 8 inputs that were creating the support system for Green Revolution.
Rural electrification.
Yes, beta, pardon?
Rural electrification, sir.
Rural electrification means villages where no having the electricity.
Yes, sir. Yes, sir.
So how they started, because if you want flood irrigation, then pump set is required, and pump set mostly run by the diesel engine. Okay, so to make the cheaper, because agriculture costs are low, so make it cheaper. Government started electrification of the villages. That is called as the rural electrification. Okay, so that was easier for the irrigation. Because irrigation problem is there. Every time you cannot see rainy season. You have to maintain the proper water level. Getting my point?
Yes, sir. Okay, sir. Thank you, sir.
So thank you so much. So you can see the statistic of Green Revolution in India. Rice production was very high, more than 80,000 million tons. 18,000 tons up to 1990. And wheat was having the same result, not 80,000, but it was below 60,000. So what is the limitation of Green Revolution? Green Revolution house were impressive but not 100% successful. Only Punjab and Haryana states showed best result of the Green Revolution. New farming technique have been given birth to serious pollution of drinking water, causing cancer, other disease. And recently, Punjabi University Patiala studied that most of these cancers are going to arise among the farmers itself. So that's again, now people are thinking of new organic fertilizer rather than the chemical-based fertilizer. Okay. And also, because of chemical-based fertilizers, there is a other health problem, and also because people were now having the less earning because of agriculture. So unemployment was more there, immigration was more. So this is all about the limitation, but achievement was much higher at that time. And now you can see a lot of corn, wheat, soybean. There are tremendous growth.
Sir, excuse me, sir.
Hmm.
Sir, what is the reason behind, sir, that only Punjab and Haryana is in the progress of green revolution, and why not the other state?
3 to 4 state were selected for the experiment because this is related to the area of the cropping. The Haryana and Punjab, you'll see, they have the 800 acres, 600 acres, 200 acres. Rest part of the country, farmers are having very small area. So far, if you are thinking of commercial cropping in 2 acres or 3 acres, this is not going to be very viable. Understanding, getting my point? And now the people of Punjab, they were growing the wheat in 800 acres, right? Then if the 5-time grain yield is there, you can see whatever the inputs cost is there, they are earning also in the multiplication of 5. Okay. Suppose you are growing potato in 1 acre and one farmer is Abdesh is growing potato in 800 acres. So who is going to have a larger yield and larger benefits? Bhaswar, tell me. Abdesh is obviously going to yield because they have a larger cropping yield. So they are,
yes, sir.
They are collecting more money. Why they are going to do the job? 1 acre farmers will do the job. They will look for the job because they have very marginal benefit. So that was the major issue. Punjab and Haryana people were having much more lands beyond expectation. 200, 300, 400. In the north, you can see from where I belong to, they have very small. I have 2 acres only. Total land, I have 2 acres. Not more than that. What I can do? Obviously, so I will have a very less margin of the benefits. Commercial viability is not there.
Sir, and I think that, sir, that was the cause, sir, due to many Haryana and Punjab peoples were involved in the farmers movement.
Yeah. That was the basic reason because they have a lot of money to pour out, lots of money. So actually, if you see, they adopted the technology, old technology, 1956 technology they are still using. You can see the graph. From 1950, this was the actual average yield of the grain, corn, wheat, soybean. Now 2002, this much was there. So because of green revolution, this was the benefit. But now a lot of new techniques have been arrived, but they are not using. For example, organic, many organic pesticides are there, organic fertilizer are there, of the same cost, not much. Even you can produce them. If you have a large facility, means if you have suppose 100 acres land, okay, so you can produce your own inputs. You can have the dairy, you can have the cow, you can sell the milk, and you can have your own biofertilizer, vermicompost you can develop your own Agni Astra, Bijastra, right? So already AGC farm is doing very good work in that area, right? We are using the fish nitrogen, not urea. Urea is the chemical base. And also a lot of nitrogen is there in the fish urine, okay? Because they are uricotic.
We are using Azola too, sir. Azola.
Azola is very good. But that you can spend some money for that, buying the Azola. While fish farming is the dual benefit. If you have some larger area, then you can grow the fish, you can sell the fish also, and free of cost, urea from them. Just move the water, add fresh water in the fish pond and take out the nitrogen rich water in the crops. That we are practicing. And also we are not harvesting the water from land, right? We are collecting the rainwater. That also beneficial. It's a use for the building materials. And it's also going to, if you are going to purify them, also we can use for the irrigation purpose. A lot of modern techniques are there. That is free of cost. You can see are very marginal, very low cost technique. People should adopt. Why do we spend a lot of money over the chemical pesticide?